One final thing I want us to have a look at is the effect of blocking. So basically I've taken the data that we looked at earlier where we had 3 different gels and we're looking at protein concentrations on those gels for a control and a treatment. And you saw how by logging and by using a paired t-test we could dramatically improve the significance of the analysis. I've extrapolated that here to include 4 different treatments and a control. So you couldn't analyze this by t-tests because there's more than 2 separate treatments. So first up, let's have a look at this and analyze it completely randomized design. So data analysis, ANOVA, single factor, OK. There's my data. Data in columns, got labels in the first row, new worksheet ply, OK. So it gives you average values for the different treatments. You can see that they are actually quite different in the average amount of protein. But when we go to look at the gel, we see that the statistical analysis shows that there is no significant effect of treatment on the protein levels. We have a non-significant p-value here. And the reason for this is largely because there are quite large gel-to-gel differences between the protein levels on the different gels. We can get around this by using a technique called blocking. So basically, if we believe that something is actually going to vary from one experiment or one day to the next, or one experiment to the next, then we try and keep the material within a block as homogeneous as possible. So we have one person actually extracting the material, putting it onto a single gel, running the gel, staining the gel, characterizing the amount of protein on the gel all at the same time. And we could do this at different days. And on different days, if it's a different experimenter who's actually running the gel, as long as that one person actually does everything, or if you have a different sample of the reagents that you're actually using, use it, but use it with everything on a different day. And that way, any differences from one day to the next actually go into blocks. So each one of these things here, each row, is a block. And we're going to try and keep these as homogeneous as possible at the expense of variation from day to day or from block to block. And the way that we do that in Excel is ANOVA 2-factor without replication. So we're OK. Our input range this time, we need to include a column which has the gel on it. We've got labels in the first row, we want a new worksheet ply, and OK. So this time we get 2 different kinds of output out. We get a summary for gels 1, 3 and 5, which shows you that there are indeed different average amounts of protein on the 3 gels. And we also get average values out for control, treatment 1, 2, 3, 4. And this would suggest that there are indeed different amounts of protein associated with the different treatments. When we have a look at the ANOVA, we see now we actually have 2 sources of variation besides error. We've got that which is in rows, which is the gels, and that which is in columns, which is treatment. So we had 3 different gels, therefore 2 degrees of freedom associated with gels. We had 5 different treatments, so control and 4 different treatments, so that's 4 degrees of freedom associated with that. The total degrees of freedom is the same, but we now see that there's a very highly significant effect of treatment on protein levels, and a very highly significant, or very, very highly significant effect of the gels. So the gels are contributing a lot to the variability in the data, and by using this randomized block technique, we're taking out the day-to-day variability in your experiment to end up with a significant finding where there wasn't a significant finding before. So we've improved the efficiency of the analysis by using blocking. Finally, I would say that if we compare this to the factorial ANOVA, you'll see that there's no interaction term here. So it's assumed that whatever's happening in blocks has the same effect on all the different treatments you're actually using, and that there are no interactions between blocks and treatments.